Okay, so today what we're going to do is we're going to begin our chapter 20. And chapter 20 is really about statistics, but you're going to see that they begin by just organizing information. So it's going to look very similar to what we've been doing with the charts and graphs. Because in order to be able to review and analyze data, you need to have that data in a very organized way. So that's what we're going to talk about today, different ways of organizing the data. So the first thing we want to do, though, is talk about what does data mean. And data is simply the information that you gather. And it could be about anything. So just title this 20A, data and dot plots. And the definition of data is simply the information you gather. So say, for example, I did a survey of you guys asking what you did this weekend. And I could write all those things down. Those things that I write down are the data that I would collect in that particular survey. Okay, so you look here in the purple box, they've got a little survey there. They've gathered gender, weight, color, etc. for some dogs, or actually some frogs. Sorry, frogs. And all right, and all of these different categories of data were collected. Yeah, and you'll see that some of the data looks a little different. For example, if you have gender, you're going to get male or female categories of data. So in other words, it's not a number that you get. But say, for example, you're talking about distance from the water source in meters, that would be numerical data, a number value, okay? And you need to be aware of what kind of data that you're going to get back, okay? So let's talk about that a bit. And I got to stop saying okay so much. All right. So the first thing we want to talk about is something called categorical data. Okay? It's where every observation falls into a number of distinct categories. So those categories that you saw, that first column in the purple chart, the sex, the color, the distance, etc., those are categories of data, right? And it helps you organize your work to separate things into category. Sometimes that categorical data can be a number, if that number is like a count. Okay? So for example, the number of children in the family, the number of people at an ATM line, etc. So count data can also be considered categorical data. You can also have what's called measurement data. When you have measurement data, you're taking a specific measurement and you must be incredibly accurate when you do that, right? If you're going to put things in a study. So you can't just guess, you need to make sure that you're measuring accurately. So different types of data that you can have. Now you're not going to be asked to define these in this course, but as you move forward, you will, all right? So keep those in mind as we go. Now, more importantly for us are ways of organizing these data. And the most common way of organizing data is what's called a frequency table. Frequency just means how often something happens. Okay? So what you're going to do is you're going to create frequency tables for data. So frequency, again, simply means how often each category occurs. And the easiest way to do this is to organize things in a table so that you can then take that information and put it into an appropriate display and help you organize it. Now, the first thing is you're going to use a tally, right? So say, for example, I'm asked different people a question and 4 people respond. So I asked you, would you prefer Coke or Pepsi? And one person preferred Coke, another preferred Coke, then the next 3 preferred Pepsi, right? A tally. You've done this before. What happens if I get to 5 people who like Pepsi? Yeah, do a little diagonal line, right, to hold it together so that then you can count them easier in 5s, yes? So a tally is a very important part of a frequency table. And all it is each individual thing in that category gets 1 tally mark. After you do that, then what you're going to do is you're going to add them up. So in this case, the frequency for Coke would be 2. The frequency for Pepsi would be 5. And this number represents the frequency. Not the tallies, but the actual number itself. So again, it just means how often. Tallies just allow us to have an easy way to count up the data when there's a lot of it. If there's not very much of it, it's not that big of a deal. But if there's a lot of it, it's easier to do as a tally. Okay? And again, you've just used tallies before. Most of this is just going to be about the language. So here we are. So we have an example of data, and here is a frequency table. I want to point out some things about the frequency table that you need to make sure you know. First of all, you must title the thing that's being measured, what the categories, what the thing that being measured is, and notice it also has units on it. If you leave that off, then your frequency table is wrong. Then each category gets its own row in the table. Rows go across, right? Then you're going to have your tally, and then you're going to just count up the tally to get the frequency. Yeah. So here, for example, how often did 35 occur? So they just went through and counted them up. And as you're counting them, it's often good to mark them off in your list so that you don't count them the second time. And so the frequency of 35 is 6. Again, it just means how often it occurs. So 3 columns of your table. The thing you're measuring, and the categories, each specific item, response, then your tallies, and then your frequency. All looking incredibly familiar so far, I hope? Good. One of the ways that you can organize this data is into what's called a dot plot. Now, what you have to remember about dot plots is that each dot represents one or more items. They don't have to always be one. For example, if you had 40 of something, you wouldn't want to do 40 dots, right? You could do each dot represented 5, or each dot represents 10. You can change it. But if I do change it, what must I include on my... A key, exactly. Some kind of scale to tell me that I have changed it. Otherwise, you have to assume that each dot represents 1. Okay? But it's just safer to put a key on everything that you do. So in this case, if you look, there were 6 35s in that last example. And so there are 6 dots stacked on top of each other. So this is very much like the bar charts, except instead of the height of a bar representing the data and then coloring it in, we have single dots representing the data, and you just count them up. Right? Now this is really good if the amount of data you have is small, but if you have a lot of stuff, this could get very tedious very fast, right? But it is good when the data is very small. And it helps you to define a few pieces. For example, the one that occurred most, in this particular case, was 39. The one that occurred least, you didn't have any 36s or 38s. So you can read some information or gather some information pretty quickly from a dot plot. Okay? Again, remember, think about why you would use a specific plot as well as being able to make them. Another thing that you need to make sure you notice, the title. Your graphs and charts are worthless without titles. If you have no titles, then it's completely wrong. So be very careful about that. Okay. So here you go. You have another example. They don't include the frequency table. You don't have to unless they ask you specifically for it. Usually the frequency table is just for your own information, but then they give you the dot plot. And what do you notice about this particular dot plot? That it's decreasing, right? The more visits. So most people made fewer visits, right? So you can see that it's decreasing as you go along. So again, it's a little bit of data that you can look at just looking at it. How many people went 0 times? You just have to count them up. So do you see some limitation there, right? You'd have to count up all those dots to find out. Okay? So dot plot's something you've done before. It's all good. So we're going to move on into some statistical measures.